and then you're going to find the opposite. The adjacent and the hypotenuse, when you trace the angle, those two are going to always be touching, which is why I normally have you find those first. So there's our review from what we had done earlier last week. So we'll set up a couple of those fractions just exactly how we were doing them last week before we start the new concept. So let's look at number 1. We're going to find the sine of angle C. Well, here's angle C. We mark that. And the sine of C is going to be equal to opposite over hypotenuse. So which of these lines is the hypotenuse? 29, 20, or 21? Good, 29. So hypotenuse is going to go down there. And then the opposite, right, if you trace this angle, hypotenuse and adjacent are going to be the two lines that get traced. So the opposite must be 21. So the sine of C is going to be equal to 21 over 29. And that's what we were doing last week, is just setting those up. Today, we're going to start using these trig ratios to solve for missing angles. So for example, to work backwards and find out what measure angle C is. Or maybe you know what angle C measures and you need to know how long the hypotenuse is, but you only have one of these sides and so you can't do Pythagorean theorem. Okay, so slide on over to number 13. As you can see, the instructions say find the missing side, round to the nearest tenth. You will very, very often see rounding instructions for these problems because these are not going to be a set of numbers that come out to nice, pretty, clean, whole numbers every time. This is why we're using a calculator. Remember in the days before, everybody had calculators at their immediate disposal. There were tables and charts where you would look these things up. These are not quick, simple, easy calculations. So please be careful to read the instructions on your problems and your assignments because they're not always going to tell you to round to the same thing. This one is the tenths. IXL, I think, usually does the hundredths. On Edge Elastic or Mastery Connect, you might have something else entirely. So instructions are going to be important. So here's what you're going to do. First, you're going to identify the angle that you need to use. If you'll remember from last week, I told you you're never going to be using the right angle because that would mess up all of your labels. The hypotenuse has to be the hypotenuse, but it would also have to be the opposite if we use this angle, and you can't double up on your sides and your angles like that. So we're going to use this angle that's 59. And then we're going to go ahead and label our hypotenuse and our opposite and our adjacent. So the hypotenuse, of course, is 17. If we traced the angle we're using, the adjacent is over here, and that means this is the opposite. So you have a decision to make at this point. You have to look at what you're being asked to find and what you have, and then you have to decide if you're using sine or cosine or tangent. I'm going to rewrite SOHCAHTOA right up there just so it's close. We know we have to use the opposite because that's what we're solving for. We also have the hypotenuse. So if we have the opposite and the hypotenuse, we must be using the sine. Okay, so that decision came from what I needed. I needed to use the opposite to find it. And what I had to use the 17. So I'm going to set up sine of 59 degrees equals x over 17. This is the same sort of fraction that we just set up back on number 1 to kind of jog our memory from last week. The only difference is instead of an angle name, we put a degree measurement in there. And instead of filling in two numbers, one of them we're trying to find. So what you need to remember is sine of 59 degrees, it has a number value. Sine is changing the 59. It's not just 59 anymore. It's like saying square root of 59. There's a 59 in there, but the other part that's in front of it, it's changing it. So what you could do at the beginning to kind of help you feel more comfortable with it is you could actually just go ahead and evaluate sine of 59. Let me grab my calculator. You do the same thing. All of these on your calculator are beside the 7 over there under that little trig button. So I'm going to make sure I'm in degree mode. Okay, so sine of 59 is about 0.87 blah, 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 blah. 857, sorry. Now, if I want to round my final answer to the nearest 10th, I'm probably going to keep a couple of extra decimal places in my work. So I'm just going to replace sine of 59 with what it's approximately equal to, and it's about 0.857. So I'm going to say 0.857 equals x over 17. And then from there, it's a pretty simple looking equation. This should look like stuff that you have solved in the past. What are you going to do to undo divide by 17? What undoes division? Good. So we're going to multiply by 17 on both sides. And there you have it. You've solved for x. You're just going to multiply 17 times whatever this is. In your calculator, if you'll just leave all those decimals and go ahead and hit times 17, that will be a little more accurate even than what you had. So 14.6, because we want to round our final answer to the nearest 10th according to our instructions. So 14.6 is our rounded answer. And there you go. Very, very easy. It looks a lot more complicated than it really is. Let's look at number 14. So which angle are we using? How many degrees is it? Good. So let's mark that, and then we're going to mark our hypotenuse and our adjacent and our opposite. 17 is the hypotenuse. Trace the angle to find the adjacent, and then the opposite's over here. Which side am I trying to find? Opposite, adjacent, or hypotenuse? Good. Trying to find the opposite. So I know I've got to use something with opposite, one of these two. And then I have the hypotenuse, so I probably should use that one instead of the adjacent. So O and H is going to be which function? So we're going to use sine again. Sine, what goes right here next? Should be the angle, right? How many degrees is our angle? Good, 60. So sine of 60 equals opposite over hypotenuse. Now, if you're okay with working with sine of 60, you can actually just type this into your calculator from here and you can be done. Because sine of 60 times 17 is exactly the same thing we did last time. Even times the same number, right? When I multiply by 17, I have solved for x. So in your calculator, let's type it all in one step this time. 17 times sine of 60. 17 times sine of 60. And there it is. So 14.7 is our rounded answer this time. So if you want to change it into a decimal, your sine of whatever, or your cosine of whatever, or your tangent of whatever, if you want to change that trig function into a decimal, if that feels more comfortable for you, you're welcome to do that. It's an extra step though. If you don't want to do the extra step and you're comfortable saying, okay, sine of 60, I'm just going to type it in the calculator, you can solve, you can work all of the other steps while leaving this sine of 60. And actually that gives you a little bit more of a precise answer because you haven't rounded it at all. Let's look at number 15. 15 is going to be a little bit different. We've got our angle. Our angle's down here at 27. Find our hypotenuse, which is 20. Trace that angle to find our adjacent, which is over here. And then our opposite is across the triangle. So now I need the adjacent. So I must use the adjacent in my equation. Otherwise, I'm not going to be able to solve for it. So I have to use adjacent. And I have the hypotenuse. So adjacent and hypotenuse are cosine. Adjacent, hypotenuse. So I'm going to set up cosine of 27 degrees equals adjacent over hypotenuse, x over 20. If I wanted to solve this in one step, what would my one step be? You're trying to get x by itself, so I need to undo divide by 20. Very good. So that cancels with that. And I'm just going to type 20 times cosine of 27. And that's it. That's all you have to do to solve. So 20 times cosine of 27, 17.8. Okay. I want you to try to set up number 16. You can solve it if you want to, but set it up for sure. Setting up is what I've done, like cosine 27 equals x over 20. So first step is to find your angle that you're going to use. Then label your sides to see what you've got and what you need to find. Once you know which sides you have, this one should be adjacent and hypotenuse. See which of those trig functions uses adjacent and hypotenuse. And then you just write it down. Okay, so adjacent and hypotenuse was what? Sine, cosine, or tangent? Very good. And my angle is what? Very good. And then adjacent is 10, hypotenuse is x. Okay, so here's my angle across from the 90s hypotenuse. Start at the hypotenuse, trace your angle to find the adjacent. This one must be the opposite, just to kind of verify. All right, now this one is a little bit different because our x is in the bottom. On all the other examples, the x has been in the top. That's okay. It's just going to make this 2 steps instead of 1. So cosine of 51 is just a number, right? If we want to, we can turn it into some decimals. Let's do that just for this first example. Cosine of 51. So it's about 0.629. So I'm going to replace this with 0.629. All right, so I want to get x by itself, but I've got to get it out of the denominator of this fraction. So I'm going to multiply by x on both sides. Now the x's have canceled over here and my fraction is gone. So I just have 0.629x equals 10. And that looks like a much easier equation to solve. We're going to take this x and we need to undo times 0.629. So I'm going to divide by 0.629 and I've got to repeat it on the other side. So you're going to type in 10 divided by 0.629 because those are going to cancel. So 10 divided by 0.629 and it's 15.9. And there it is. Now, you don't have to change it into 0.629. You could leave this as cosine of 51. So you could actually type 10 divided by cosine of 51, and you should get approximately the same thing. Let's watch and see. I don't want to miss anything. So see, the decimals are slightly different, even out to this third decimal place. And that will make a difference if you're rounding to the hundredths or to the thousandths, right? Because if I had rounded to the hundredths, the second decimal place, this I would have said from our first calculation, it would be 15.90, right? 5 or above, give it a shove. So this second 8 is going to make this 9 jump up to a 10. But down here, when I type in the exact value, cosine of 51, it's actually just a 0 right there. So I would not round it up to 0.9. It would be 15.89 instead of 15.90. Now, that's not a large difference in reality, at least not for what we're doing. But if you're talking about the difference between a right answer and a wrong answer on something like IXL, it does make a difference because IXL does have you round to 2 decimal places. So for the reason of rounding and precision, I feel like it's better to leave these as cosine 51 or sine of 27 or whatever it is you're using. Leave the trig ratios there rather than rounding them. Now, if it means that you can, if it feels like you can't do it because you don't understand it, okay, that's the only time really that you need to swap these out. But just be aware that sometimes you might miss them because of rounding. So I would encourage you, try not to change these into numbers. As far as practicality goes, it's the same thing. But in terms of getting all the right answers versus most of the right answers, they are going to be a little bit different. So let's look at 17. And from here on out, I'm just going to keep this as cosine 51 or as cosine 27 or whatever. Just realize that it is a number on its own. So 17. We've got our angle. We've got our hypotenuse over here. This is our first one where we're not using the hypotenuse because it's blank. We don't have any information about it and we don't need to find it. So we're going to trace it to find our adjacent side. Our adjacent is right there. So this must be our opposite. So I am finding the adjacent and I have the opposite. So which trig function is that? Sine, cosine, or tangent that uses O and A? SOHCAHTOA. Thank you. Tangent. So we're going to do tangent of 40 equals opposite over adjacent. Okay. I'm going to put tangent of 40 in parentheses right here just to keep us, realizing that it's a number. It's not 40. It's a different number. So now when we solve, we're going to multiply by x because we really want to get rid of that fraction. Okay. So in our next line, that's where we got rid of the fraction. Our next line, we have x times tangent of 40 equals 20. And you can put a little dot out there for times if you want to. Keep in mind your goal is solving for x. So we got rid of the fraction. That was kind of a problem. Now we're still trying to get x by itself. We need to undo times this amount. Well, we undo times with division. And we need to divide by the same amount that we're trying to get rid of. We're trying to get rid of tangent of 40 over there. Okay. So this cancels with this. That's what we've set it up to do. And we're ready to just type the rest into our calculator. So 20 divided by tangent of 40. 20 divided by tangent 40. So it's 23.8. 23.8 units long. And there we go. All right, so what I want you to notice before I have you try number 18 on your own, regardless of where the x is, whether the x is on the top of the fraction or the bottom of the fraction, regardless of where the x is, the first thing we did was get rid of the fraction by multiplying times the denominator on both sides. So up here, our denominator was 17. We multiplied times 17. Up here, our denominator was 17. We multiplied times 17. Our denominator was 20, so the first step was to multiply times 20. Our denominator was x, so we multiplied times that denominator x. When our denominator was x, we multiplied by our denominator of x. Whatever the denominator is, multiply that first because you want to get rid of the fraction first, regardless, okay? So with that said, I want you to try number 18. If you want to pause after you've set it up, then I will check that step for you, but ultimately I do want you to try to solve it without my instruction. Of course, we'll check it. All right, so first thing that you need to do is you need to set it up. So you're gonna, yes, sir. Sure. You're going to pick your angle, find your hypotenuse, trace that angle to find your adjacent, find your opposite. Then check and see what you're looking for and what you have. O and A, because you need O and you have A. Those are the two letters in SOHCAHTOA that you got to use, the O and the A. So in SOHCAHTOA, there's our O and our A. We're using tangent of 53 and it equals opposite over adjacent. So questions about setting that up. One of the most common questions is, how do I know when to use sine, cosine, or tangent? So I've tried to really emphasize that as we've gone over it today. Everybody good on why we use tangent? Okay, so then what's my first step? Very good. Always, whenever you have a fraction over here, and you will, because that's how these are all set up, they're all fractions. That's why we stack these letters this way. You multiply times that denominator. Okay, and then that's it. X is solved for, it's over here by itself. So we're just going to type in 12 tangent of 53. 12 tangent 53, 15.9. All right, so what questions do you have? Looks a lot harder than it really is, isn't it? Okay, so that is solving for sides. The other thing that you could solve for is the angle. And the angle is going to be over here with your sine or your cosine or your tangent. So it has a little bit of a different process. So what I want us to do is over here above this, because this is kind of our notes. It's really just a bunch of practice that we do together. We're going to put solving for sides. Because that's how we did it. And then the other thing that we talked about was always multiply by denominator first. Always multiply by denominator first. Sometimes that's all you have to do. Sometimes you have to divide by the trig ratio as well. But always you multiply by the denominator first when you are solving for a side. All right, so you ready for the easy part? What? That wasn't the easy part. Man, how awesome is this? Okay, so on the back, we're now solving for angles. Find the indicated angle. Solving for angles. We still need SOHCAHTOA. So I'm going to go ahead and write it above our instructions once more. SOHCAHTOA. Again, make sure you say it right. Don't add some syllables where there aren't any. It's not SOHCAHTOA, it's SOHCAHTOA. SOHCAHTOA. All right, so SOHCAHTOA. What we're going to do here is basically the same process to get us started. We need to evaluate what we've got and what we're looking for. But on this side, as you can imagine, we're going to be looking for angles. So here's the angle we're trying to find. It's already conveniently marked for us, as it should be. If they're wanting us to find it, they need to tell us which one it is. We're still going to continue labeling our H and our O and our A because we need to see which trig function to use. So across from the 90 is the hypotenuse. Trace the angle we're finding to find the adjacent side, and then the opposite side is over here. So we've got O and H, opposite hypotenuse. Here's our O and our H. We must be using sine. So we're going to put sine of X. That's what we're finding. We don't know that angle measure, so we're making it a variable. This might also be where you see theta. We'll do that on the next one. So sine of x equals O over H. O is 39, H is 44. Okay, so when you tap that button that says trig, all of your trig functions have an inverse function. In math, every function has to have an inverse. If I can change a number with a certain process, I need to be able to undo that. So addition and subtraction undo each other. Multiplication and division undo each other. Well, sine and sine inverse, or arc sine, they undo each other. And all that is it's just the sine with a little -1, just like that. And that's all you're going to do is to solve this, you're going to use that sine inverse. So you're going to take the inverse sine of both sides, well, sine -1, sine -1. That's not what it really is, so don't say that. And so this cancels out with this, very much like the 2 exponent cancels out with the square root. The processes undo each other. So I'm just going to type this in. So the sine inverse of 39 over 44, there's your answer, 62.4 degrees. Actually, this one says to the nearest degree, so whole number, 62 degrees. And y'all, that's all you'll do every time. You set up the fraction, sine, cosine, or tangent, and if you're solving for an angle, it's one step every time. And that step is simply use the inverse. I know, it is easy, isn't it? All right, so let's look at number 20. Find our angle that they want us to find, or I guess locate our angle they want us to find. Hypotenuse is over here. Trace that angle to find the adjacent side, and then this one is the opposite. So once again, we're using sine, S-I-N-E, because we've got opposite and hypotenuse. Those are the 2 numbers that we have. So I'm going to do sine of theta this time, just to get us used to seeing theta. Remember, theta is a Greek letter, and we just use it for angles a lot in trig. So you could use x if you're writing these on your own. But again, I just want you to be used to seeing theta, because sometimes that's what they have. We set up our opposite over hypotenuse fraction. And yeah, I got those right. And then we take the inverse. Okay, now when you're doing this on your own, you don't necessarily have to write all this down, but because this is our notes, this is our practice that we're doing together, I'm writing down every single step. So this cancels with this. That's why we write that way, to show that it cancels. And then theta is equal to inverse sine of 26 over 33. Type it in. There it is. Now we're rounding to the nearest degree. So this one's going to be what? 52. And there it is. One step, very easy. 21. Locate the angle they're wanting you to solve for. There it is. Label your hypotenuse. Trace your angle to find the adjacent side. Here's the opposite, just to be consistent. So which trig function am I using now? It's not sine anymore. Cosine, good. Because we've got a and h are the numbers that we're given. So the fraction that uses the a and the h is what we've got to use. And so cosine of theta, you could put an x. It's just a variable. You could put a smiley face. I mean, it really doesn't matter. It's just a placeholder. So cosine of theta equals 24 over 36, because cosine is adjacent over hypotenuse. The adjacent is 24. The hypotenuse is 36. So now we're just going to hit that little inverse for cosine instead of sine. The inverse of cosine cancels with cosine, but we've got to keep it the same on both sides. So we type in the inverse cosine, and 24 over 36. So 48, because the 1 won't make it round up, it's just 48. Theta equals 48 degrees. What questions do you have? Okay. Yes, ma'am.
Okay. How do you know which one is the
Okay, so when you label your sides in relation to this angle, and they all had more practice on this last week, so I'm glad you're asking. This will get you caught up. When you find the angle that you're using, you're going to label your sides, right? So hypotenuse is over here because it's across from your 90-degree angle. And then you trace that angle to find the side that is adjacent to the angle. And then I'm going to go ahead and put the opposite because it's the only one left, even though you're not going to use it in this problem. So the way you know which of those functions to use is to look at which angles, or I'm sorry, which sides you have. So I have a measurement here and I have a measurement here. So I'm going to use the A and the H. So in my SOHCAHTOA memory device up here, the A and the H are cosine. And that's how you know which one to use. Does that help a little? Thank you for asking. So we're going to do cosine of theta equals that A number 20 over that H number 25. Okay. Are you to the point now where you can just type it in? You don't need to rewrite it? Okay. If that's you, then go ahead. I'm going to go ahead and write down our steps just in case. So I'm undoing cosine with inverse cosine or arc cosine. Sometimes you'll see it different ways. 23. Sounds good. I'm going to type it in just to be sure. Oh, thank you. Thank you. Whoops. That would make a difference. I wrote over it and it looked wrong. Thank you. 20 over 23. So about 30 degrees. And really, I should be putting approximately in all of these, but it's going to be okay. Because it's not exactly 30, right? We rounded it. It'll be okay. We're not going to split hairs over that. Okay, so I feel like we're probably good with this. I think 4 examples is probably about all that you need because it's literally just picking the different button with the inverse. I do want to spend some time talking about these. Now, these word problems, you're going to have to draw and label your own diagrams. So over here, we're going to put up at the top word problems. And then always draw the diagram. Now your diagram does not have to have an exquisite amount of detail, right? You're not doing the Sistine Chapel ceiling for these diagrams. You're just sketching out a triangle is really all you need. So different triangles are going to be turned different ways based on your context. I'm actually going to start with number 33 because I feel like it has the most understandable context for everybody. So in 33, it says a 9.0 meter ladder rests against the side of a wall. Well, everybody in your head can imagine what a ladder leaning against a wall is going to look like. I'm going to draw my wall here, and I'm going to draw my ladder here. If you want to draw your wall going up higher than the ladder, that's fine, but you don't need the part above the ladder. You're just going to need the part where the ladder and the wall meet. So the ladder is 9 meters. Well, the ladder's the one that's going to be slanted, right? So I'm going to put 9 over here. And then it says the bottom of the ladder is 1.5 meters from the base of the wall. Well, that's going to be this ground down here, and it's 1.5 meters away. And it says determine the measure of the angle between the ladder and the ground. Well, the ladder meets the ground right here to the nearest degree. Okay, so you just sketch it based on common sense. You know what a ladder leaning against a wall looks like. Again, if you want to draw it with more detail to help your brain process it, you feel free. But at minimum, you just need a triangle. You know it's going to be a right triangle because you've got the ground and a wall. Typically, that's assumed to be 90 degrees. If the ladder's 9 meters, you knew where to label the 9 because you label it where you drew the ladder. And yours might be turned the other way. You might have drawn the ladder out like that. Either way, that should be 9 and that should be 1.5. And then this is the angle between the ladder and the ground. So whichever way you work it, it ought to be fine. Okay. And now it's one of these super easy problems over here. So we've got our hypotenuse. Here is our angle. When we trace it, this 1.5 is the adjacent. So we've got A and H. So TOA, A and H. That's cosine. So cosine of theta equals 1.5 over 9. Now, is this one where we multiply or is this one where we type it in? Good, just type it in. Whenever you're solving for the angle, you just type it in. So you're going to do the inverse cosine, 1.5 over 9. You don't even have to simplify that fraction. So it's about an 80-degree angle. Okay. Let's also skip down and do number 36. Number 36, a person flying a kite has released 176 meters of string. Okay, so the string, if you're flying a kite, it doesn't go just straight up above your head. So the kite string is going to go out this way or the other slant, it doesn't matter, but it's your slanted line. And it is 176 meters long. The string makes an angle of 27 degrees with the ground. So here's the thing about flying a kite, right? This person right here that's flying this kite, I probably should have had them touch the string. That'll be okay. The kite string doesn't go all the way down to the ground. So what you have to do is you just have to kind of imagine a parallel line, right? Because we know, because of parallel lines and transversals, that whatever this angle is, it's 27 degrees with the ground. If we make a parallel line at the point where the person's holding the kite string, that's going to be 27 degrees also. Okay, so don't get hung up on the fact that the person's not like laying down on their back flying a kite. Of course, I guess they could be. I don't know, doesn't say. Don't overthink that. So this angle is 27 degrees. And it says, how high is the kite? So that is this line right there. That's going to be our x. Let's solve that first before we go with the other part. So I have this angle 27. Here's our right angle. So this is our hypotenuse. Is x the adjacent or the opposite? Good. So opposite and hypotenuse, so katoa, O and H, that's sine. So we would just do sine of 27, opposite over hypotenuse. All right, x is not with our trig function, so this is one that we're solving by getting rid of the fraction. So what do we do first to get rid of the fraction? Perfect. And then we can just type this in. 176 times sine of 27. 176 times sine of 27. So it's about 79.9. We'll round it to the nearest whole number. So 80 x is approximately 80. And this is in meters. Okay, so that was the first question. It actually asked us 2 questions. Second question is, how far away is the kite horizontally? Okay, so horizontally, let's make this y since we've already used x. Y is right here. How does that change our problem? Instead of sine, we now need right. So this is this the adjacent? Well, no, I'll just say this is the adjacent side, right? So we've done this one. We now need adjacent and hypotenuse. So which trig function is that? Cosine. So now we're just going to do cosine of 27 equals y over 176. So the only thing that changed there was cosine. Now, let me just point out as well, since you have an approximate value for x, you could technically use 80 degrees right here and like use Pythagorean theorem to solve your missing side. But to be really honest, y'all, this is easier than Pythagorean theorem. It's far fewer steps because all you're going to do, you're going to multiply times 176 and then just type it in your calculator. It's also a little bit better to calculate it this way because it doesn't rely on using an approximated number, right? 80 degrees is not the precise number, but cosine of 27 is the precise number. So your answer is going to be a little bit more accurate because you didn't rely on a rounded calculation to find your next number. So that's why I didn't do that. But if you're on a quiz or a test or something and you're struggling to figure out what to do, you can always fall back on Pythagorean theorem if you're just missing one side. So it is 157-ish meters away. All right, so some of the problems that you will see will say something like, solve the triangle. Okay, let me put that phrasing down here. Solve the triangle. What that means is find all the sides and all the angles. So we have almost solved this triangle. We have that 90 degree right there, and we have the 176 that we were given. We also have this 27 that we were given. I'm going to use a different color to do the parts that we have found. We found that this side was about 80 meters. We found that this side was about 157 meters. So all we're missing is this little angle up here. How can we find this angle? Perfect, 180 though. But yes, very good. So we get 63. So that's all we need, 63 degrees. And you have solved the triangle. Okay. So the only thing that we did that was extra was this 63, just for the purpose of you knowing what solve the triangle means. Now, some other common terminology that you will need to be aware of for these word problems are angle of elevation and angle of depression. Okay, so 31. An airplane is flying at an altitude of 6,000 meters over the ocean directly toward a coastline. At a certain time, the angle of depression to the coastline is 14 degrees. Over here, from a horizontal distance of 80 meters, the angle of elevation to a flagpole. The angle of elevation in 34. Angle of inclination, that's the same as angle of elevation. All right, so this is going to come up a lot. So here's the thing. The angle of depression is from the horizontal surface down. The angle of inclination is from a horizontal measurement up. So let's do a little example over here. Angle of depression horizontal It's right there, okay? That is your angle of depression. It's from this horizontal line down. So in the case of that first problem, you would have an airplane. Well, hopefully your airplane, once it's up in the air, it's going to fly at a pretty consistent altitude, right? It's not going to be like roller coastering up in the clouds, hopefully. So your angle of depression goes from the flight line of the plane down. Just think about what it would be if it were different. The angle of depression is 14 degrees. Think about what it would be if the 14 were on this side, right? Let me just do it this way. If I have a choice for my plane to go at a 14-degree angle like this from where it's flying, or my plane could go 14 degrees this way, I know which one I'm going to pick, don't you? We're going to pick the one that puts us on the ground safely. And it's not this super steep decline, all right? It's going to be this one. The other one, the angle of elevation, well, it's going to go from a horizontal, like the ground, and it's going to go up. So it's going to be in here. Okay, I probably shouldn't have put that 14. If you did it in pencil, you can erase it. So there is your angle of elevation. It's going to measure a horizontal line, plane, whatever, going up. And that's going to be how you draw these triangles. So on 31, we already kind of talked about the airplane is flying at an altitude of 600 meters. Now the altitude, that's going to be straight up and down. I said 600, it's 6,000. It's just barely skimming the ground at 600 meters. And it's flying directly toward a coastline at a certain time. The angle of depression, so over here, angle of depression is 14 degrees. How much farther to the nearest kilometer does the airplane have to fly before it's directly above the coastline? So we're trying to find this line in here, not degrees. Okay, so this is going to involve a little bit of problem solving because the angle that they gave us is not the angle inside the triangle, right? Remember, it would really suck if this was your 14-degree angle of depression because that means your plane is crashing. Okay, you don't want the 14 to be up here. But if you realize, you can do one of two things. You can, what I think I would do is realize that this angle and this angle are alternate interior. Right? Because your ground is down here. Your plane is flying horizontally. That's parallel with the ground. And then these lines, they could continue. This is like a transversal, right? So I'm going to put 14 down here, and that makes a lot of sense. The other option is that you could imagine a second triangle. You could move your altitude over here, and then you would be trying to solve, it's still going to be the same distance, but you would be measuring it in the air as opposed to measuring it on the ground. Okay, either way, totally fine. Whichever way makes the most sense to you. This is one of the hardest types of problems that you would have to do with this just because the diagram is a little bit hard to wrap your head around. But once you've got it, you've got it. You'll see similar problems to this repeatedly. So personally, I like to move just the angle. So I have the opposite and adjacent. Let me do like that. Opposite and adjacent is tangent. So tangent of 14 equals opposite over adjacent. Notice you'd be setting it up the same way on the other triangle. You would then be trying to find this. This would be 6,000. It's still going to be the opposite and the adjacent because your hypotenuse is this shared line right there. Okay. So we always, when the x is over here in our fraction, we multiply times the denominator. Happens to be x in this case. And then we're going to divide by tangent of 14. to cancel. Divide by tangent of 14. So x equals 6,000 divided by tangent of 14. And that's what we're going to type in. So 6,000 divided by tangent of 14 is about 65 feet. 24,065. Is it feet? No, it's meters. There we go. Okay. Let's do another one. 32. From a horizontal distance of 80 meters, the angle of elevation, I should have put that 80 over here. The angle of elevation to the top of the flagpole is 18 degrees. Find the height of the flagpole to the nearest tenth of a meter. So here's our right angle. We're trying to find this height. We've got opposite over adjacent again. So tangent of 18 equals opposite over adjacent. Okay. And you know how to solve them, right? You just multiply by the denominator. That's the same thing we were doing on the front of the page. Let's go ahead and set up 34 and 35. Angle of elevation of the sun. So obviously our horizontal is just the ground. Angle of elevation is going up from the ground, and that is 68 degrees. And it doesn't matter if you're, precise or not with your angle. Like it might be 5 degrees, it might be 68 degrees. Just draw an angle in there. The angle of elevation of the sun is 68 degrees when a tree casts a shadow 14.3 meters long. So here's the tree. If you want to make it a tree, you're welcome to do that. The shadow would be out here, right? So that shadow is 14.3. And how tall is the tree? We're going to assume the tree is basically perpendicular with the ground. So we're once again opposite and adjacent. Tangent of 68 equals opposite over adjacent. That's a point, not a times. Okay. What questions do you have? Okay, you try 35. I left the most concrete example for you because you know what a wheelchair ramp is going to look like. So draw your ramp, and there's the ground, and there's, I don't know, steps, front door, whatever it's going up to. It rises 0.7 meters, so that's its height. The ramp is 4.2 meters long. So the whole ramp, that's your slanted line. That's your 4.2. What is the angle of inclination to the nearest degree? So there's theta. Now, this is a very practical question. If you are planning on doing anything with construction ever, there are actual codes that tell you what the requirements are for this angle of inclination on actual ramps, like on wheelchair ramps going up to a house or going up to a business. Like they have to fall within a certain range of angle measures. So if you ever see contracting in your future, sometimes if you don't, life has a way of sneaking up on us like that. This might be actually something that you would need to do. This is one of those things like I was telling y'all last week. My dad was building a wheelchair ramp for my grandma's house, and he needed to know, he didn't need to know the angle of inclination because of the codes or anything, because the wheelchair ramp was definitely long enough. He needed to know how to cut the board. so that the board, you know, because the board is going to go up like that. He needed to know how to trim it so that it sat flat with the ground. And that's how we did this, was with this sort of problem right here. I just sketched it out and kind of helped him find the angle. So anyway, back to our actual problem. We now have opposite and hypotenuse, which is sine, and we're finding the angle. So it's sine of theta equals opposite over hypotenuse. And there you go. You just type it in. You do the inverse sign on this one since you're finding the angle. Any questions before I turn you loose to work? All right. Guys, this is all for trig, really. Like, we're going to practice it some more, but once you figure out sine, cosine, and tangent ratios, and you solve for missing sides, and you solve for missing angles, and you put some context problems with it, that's pretty much all you do in geometry for trig. So you've done really well with that. You haven't made it any harder than it needs to be, and I do appreciate that. Sometimes folks make it hard, but y'all don't seem to have. So what we're looking at now is our IXLs. If you will go to your Google Classroom, I have linked trig ratios, find a side length, trig ratios, find an angle measure. Now, I'm not concerned about your ability to do these because we've just done both of them, but I want to point out in finding an angle measure, it starts with some ugly looking side lengths, like they have radicals and stuff. That doesn't change how you work this problem, okay? You're still setting up, in this case for T, this is the adjacent and hypotenuse. So to find the adjacent and the hypotenuse, let me find some blank space and I'll work it over here for us, okay? So to find angle T, I know I've got the adjacent and I know I've got the hypotenuse. So I'm gonna do cosine T equals adjacent side over hypotenuse. And that's what I'm typing in, right? I'm still just going to type in the inverse cosine of all of that. And I'm still just going to get a decimal. You do not have to work with the radicals on your own, okay? So cosine, inverse cosine. Your calculator will do the little fraction bars for you where you can set it up to look exactly like that. And that's what I recommend. If you're doing it like I'm doing it, I need parentheses around both of those. So I'm going to do parentheses for my top, 42's on the top. And then more parentheses for the bottom. And then parentheses to close my angle. And there you go, 45. It looks super ugly, but it comes out to just plain old 45, okay? So it looks harder than what we did, but it's really not. Don't make it difficult. T equals 45 degrees. If you don't see anything about rounding, it's gonna come out to a whole number. If you do see something about rounding, just round it accordingly. Questions about that? Okie dokie. Yeah, let me know when you do get questions. I'm gonna shut down all of my stuff up here, and if you have questions after that, let me know. Just say. Yes, ma'am. Yes.